On the behalf of Government Engineering College Banswara, I Dr. Sunil Gadhwal welcomes you once again in video lecture classes. Today we are going to discuss an important topic, reforming. As in previous classes we had discussed about fuel, its classification, carbonization, types of carbonization, cracking. So in this video lecture class we are going to discuss another process in which we have to improve the quality of fuel. As we had discussed in carbonization, that the quality of fuel is also improved when we convert coal into corresponding coke, and the coke are very dense and highly energetic, giving low undesirable hydrocarbon, low pollution and all. So that's why, keeping all things in mind, the quality of fuel can be improved by fractional distillation or cracking, is known as reforming. So as we had discussed in cracking, that when a higher molecular hydrocarbon is heated in the absence of air at higher temperature, it's breakdown into corresponding small molecular weight hydrocarbon. So here adopting those basic concepts and all, we have to improve the quality of fuel. So reforming can be achieved by two methods. One is thermal and another is catalytic method. So in thermal reforming, this reforming is carried out at higher temperature, 500 to 600 degrees centigrade, and a pressure of 85 atmosphere without the use of catalysts. Your reforming is controlled by rapid cooling. As we know that when we spray oil on any vapors of hydrocarbon, so spraying oil due to its specific properties, it will take the energy from the vapors of hydrocarbon, and it will cool down the hydrocarbon suddenly. So here also we have to do the same thing. So after that, again we will after rapid cooling, we will pass the vapors in a fractional column, and from there the middle fraction will pass in a stripper, then in condenser, and we will get the desired products. So what are the changes occur during the reforming? Or an alkane means simple hydrocarbons converts into branched hydrocarbons. During this process, cracking is also occur, and the yield of saturated and unsaturated hydrocarbons will form. So here state-run hydrocarbon are passed in a preheated chamber which is having a temperature of 500 to 600 degrees centigrade. All the hydrocarbons will come out as vapors, and here in this quencher we have to spray cold oil. That cold oil will cool down them, and then by the fractionating column, this residual gas and small molecular weight hydrocarbon we will go in this condensation, and this gaseous and gasoline we can recover. And this middle and heavy oil fraction, again we have to pass in a stripper where steam is passed, and again they will vaporize, and this stripper is further connected to condenser, and we will get gas and reformed gasoline. So this is the simple process of converting thermal reforming of state and gasolines. The another reforming method is catalytic reforming. Catalytic reforming is done in the presence of a catalyst, platinum and aluminum oxide mixture. That's why this is known as plateau forming. So in the examiner sometimes gives the another name, write short note on plateau forming. So student must not be confused about that he is asking about catalytic reforming, because here plateau forming words is used and in the presence of platinum. The quality of the obtained gasoline by this method is much better than compared to the thermal reforming. It is done at low temperature and pressure in the presence of a fixed bed or liquidized bed process. The plate as you can see in this diagram, that this is the hydrocarbon which we have to reform by using this platinum aluminum oxide catalyst. So here we are having 3 chambers of catalyst, and the temperature of these catalytic chambers are 500 degrees centigrade and applied 35 atmospheric pressure. Also platinum and aluminum oxide mixture is fitted in these 3 chambers. So according to this diagram, when this fitted gasoline is first passed in a preheated chamber, from where the vapors will come out, and by the fractional column distillation, lower hydrocarbon carbon sankhya 1 to carbon sankhya 4 and gaseous hydrocarbon are separated. Then the heavy oils and tar also separated by the fractional column. Middle oil also separated. Only the hydrocarbons which are having boiling point between 100 to 190 degrees centigrade are taken up for further reforming process, and they passed collected from the fractional column and passed in a preheated chamber. That chamber is having temperature 500 degrees centigrade, and also added hydrogen gas, and with the help of a compressor the temperature of this catalytic chamber is maintained 35 atmospheric. And due to the presence of catalyst, temperature and pressure conditions, these state and 100 to 190 degrees centigrade boiling points hydrocarbon will convert into branched hydrocarbon. And as we know that during the cracking, some poisonous gas H2S and HCl will form, that also we have to remove. So to removing this we have to keep some moist Fe2O3 on these plates in this removal column, so that Fe2O3 react with H2S and HCl and make the Fe2S3, which on oxidation or on burning at higher temperature in the presence of oxygen, we will get again this oxide and plus sulfur oxides, which can be trapped in water. So from here again this lower hydrocarbon and gases are removed, and the vapors coming out here is condenser with the condenser, and then with the fractional column we will get all the hydrocarbons and according to their boiling points. Now one more short type question. Every time in examiners are putting that write short note or this write the difference between cracking and reforming. So as we know that in cracking, higher molecular weight hydrocarbon will break down into two small molecular weight hydrocarbon, while in reforming the modification of hydrocarbon has to be done to improve the quality of fuel. Reaction involves thermal cracking, and as we know the crackings are two types, thermal and catalytic. The reaction involved in reforming are thermal. This is dehydrogenation, isomerization, cyclization and aromatization. And B in catalytic reforming, hydrocracking, dehydrogenation, isomerization, dehydrocyclization, aromatization. In the cracking, generally middle and heavy oils are cracked and isolated the vapors of low boiling gasoline fractions, while in reforming, anti-knocking characteristics of hydrocarbon is improved. So in the next class we will discuss what are the reactions involving in the reforming. Hoping that you would understood the topic very well. Thank you.